Okay, welcome to part 2. I accidentally meant to hit pause and accidentally hit stop. So it takes forever to splice videos together, so here we are on part 2. Number 3, we want to find the domain of the function. So if you're given a function, the domain, you can think about it, it's going to start out being negative infinity to positive infinity, right? All real numbers. And then you look for things that mess that up, numbers we have to leave out. So here on this one, since we have a fraction, we have to make sure that the bottom does not equal 0. So we can look for numbers that would make the bottom equal 0. You may be able to just look at it and see what number that would be. If not, you just take the bottom, so 3x minus 15, set it equal to 0, and then solve that little equation. Okay, so here we'll add 15 to both sides, divide both sides by 3. We get x equals 5. So if we plug in 5, that's going to make this thing be 0. So that's what we don't want to happen. So we don't want x to be 5 here. And it says put our answer in interval notation. So it's all real numbers except 5. So the way we do that, the smallest our x's can be is negative infinity. And then we run into trouble when we get to 5. We want to leave 5 out, so we're going to have a parenthesis. And then we skip over 5. And so we have another parenthesis. And then we can go all the way to infinity without running into any more trouble. And since we have two pieces, we need a union symbol just so that we put those two pieces of the number line together. So in interval notation, there's our domain. Okay. In words, kind of words and math notation, we would say all x's except x equals 5. We wanted an interval notation, so that's what we get there. So we just want to make sure the bottom of a fraction is not 0. The only other thing we have to worry about with domain is when we have a square root. So here we don't want this thing underneath the square root that can't be negative, because if we have something negative underneath the square root, we get into complex numbers, and with functions we're only dealing with real numbers. Okay? So t plus 4 can't be negative. Okay, if you can see what value is the smallest value that will work, that's fine, you can just go straight to it. But if it's something that you can't see easily, what we're saying when we say it can't be negative is they're saying t plus 4 needs to be greater than or equal to 0. That's the same thing as saying it can't be negative. So then we would solve this, we subtract 4 from both sides. Negative 4. So this says that t needs to be greater than or equal to negative 4. So the smallest t value, or x value, if you want to think about it that way, that we can have is negative 4. And then we want all the t values greater than that, so we can go all the way up to infinity. And since we have the equal to bar down here, we're including negative 4, so we have a square bracket for the negative 4. If you could just see negative 4 was the smallest one, that's okay. Number 5 says use the vertical line test in their red graphs. Let me change the color here. Use the vertical line test to determine whether the curve is a function or not. And so the vertical line test says if we can draw in a vertical line anywhere that touches the graph more than once, then it is not a function. Here, no matter where we draw in a vertical line, it's only going to touch once. So this one is a function. Okay, part B. Ooh, I see somewhere in here, if we draw a vertical line, it's going to touch more than once. So we touch there, there, and there. So this one fails the vertical line test, so this one is not a function. Similar on part C, you draw in a vertical line somewhere in here, you can touch the graph a whole bunch of times. So part C is not a function. D, no matter where we draw in our vertical line, it's only going to touch it at most once. This one is a function. that all of them? Yep, that's all on that one. So just using the vertical line test. Okay. 6 gives us a table of values, and remember y is the same thing as f of x, so this is just like an xy table. It says find the rate of change. Rate of change is slope. So we need to pick 2 of the points on the graph, right? So if you take an x and a y, that gives you a point on the graph. So we need to use 2 of those points, figure out our slope to get our rate of change. So let's see, I'm gonna use the point 0.03 because that looks easy to use, and then I'm gonna use the point 2, -3 because those numbers are kind of small too. So I'm gonna call, it doesn't matter which one you call which, but I'm gonna call this one 0.1. I'll call this one 0.2, just make sure you don't get mixed up. Okay, so y2 would be -3 minus y1 would be 3 over x2, 2 minus x1, which is 0. And we just simplify, so -3 minus 3 is -6. 2 minus 0 is 2. -6 over 2 simplifies to -3. So our rate of change here is -3. Okay. So we're just using the slope formula. Then to get our equation in ax plus b form, this is a, and our rate of change. That's what we called m when we weren't dealing with functions, their slope. To get b, b is our y-intercept, and so b is going to be wherever our graph crosses the y-axis. So at that place, our x-coordinate has to be 0, so we're going to have 0, b. So if we look on our table, we've got a point where our x value is 0, is 0, 3. So b is going to be 3 here. So this 3 is our b. Then we just plug in, so we'll have -3x, our slope, and then plus 3, that's our b. Okay. Number 7. We're shifting some graphs around. So what's going on here? If we start with f of x, what has been done to our graph? Well, we got a +2 out here, so that means our graph has gone up 2. Then we have a +4 inside with the x. So this one means our graph has gone left 4. Remember, those are kind of backward. So we have shifted 4 units to the left, 2 units up. So that's this one. This one, I can see we've got -3 out here, so we've gone down 3. And in here, we have a -9. That means our graph has gone right 9. We have shifted 9 units to the right. That's not the one. 9 units to the right, and 3 units down. So the first one. Okay. Right now we've got some reflections mixed in. So this one has gone up 3. So since it's multiple choice, we've got 2 choices here. Then we need to know what type of reflection we've done. So remember, if we have, let's scoot this over, if we have the negative sign out in front, that's a reflection, and that is a y-axis, no, x-axis reflection, sorry. And if we have the negative inside with the x, that's a y-axis reflection. On this one, the negative is out front, so this is an x-axis reflection. So we have reflected about the x-axis. So what was up is down, what was down was up, and we have shifted 3 units up. Okay. Part B, now we've gone down 3 units. And then what does this 8 out here do? We've multiplied by 8, so we have stretched by a factor of 8 vertically. So we've stretched vertically by a factor of 8, shifted down 3 units, so that's this one. Okay. Remember, if our number we multiply by is smaller than 1, so like if this was 1/8, that would be a shrink. But since our number is bigger than 1, that we multiplied by, it's a stretch. Okay. Now we got to come up with what our function looks like after these transformations. Okay, so we're starting with absolute value of x. Let's see. It says we're going to go up 6 units, so I know I'm going to have something in the absolute value, and then a plus 6, because I got to go up 6 units. And it says we got to shift left 5 units, so that I know that means I got to, if we go to the left, that's plus 5 in here with the x. And then it says I want to shrink by 1/4, so that means we're going to multiply by 1/4. So we should have 1/4 times the absolute value of x plus 5 plus 6. Just do them one at a time. Okay, one transformation at a time. Okay, so up is plus on the outside, right is plus on the inside, and then stretch or shrink is multiply. Oops, sorry. Things getting a little crazy on me here. Where are we at? 1 second, there we go. Oh, I think we're set now. Okay. Come on, computer, there we go. Here we want to combine some functions. Okay, this is the last section that we did. We're going to add, subtract, multiply, and divide. Okay, so first, it's a good idea to think about the domains of these functions. So here the domain, if we have just x, we don't have a fraction, we don't have a square root, so it's just going to be negative infinity to infinity. For the other one, our domain, we do have a square root, so here we can't use negative numbers for our x's, so we're going to start and we're going to include 0 because square root of 0 is 0, that's okay. And then we're going to go toward positive infinity. We just can't go to the left, we can't go to negative numbers, so there's our two domains. Okay. So if we do f plus g of x, and then f of x is x, plus g of x is square root of x. So there's our new function, nothing we can do to simplify. The domain, in order for it to be in the domain, it has to be in the domain of both of these. So where do they overlap? Well, we can't use negative numbers because of this one, so we're not going to be able to use negative numbers in our new functions either. So it's going to be the domain on plus, minus, and multiplication, 0 to infinity, including 0. We do f minus g, then f of x is x, then minus g of x is square root of x. There's our new function. Again, where the domains overlap is 0 to infinity. You don't have to think about that again, it's going to be the same as plus. F times g will have x times square root of x. In the video for that section, I simplified that. That's simple enough. You don't have to do anything else with it. And the domain is going to be 0 to infinity again. And then for the last one, dividing, we're going to have x over square root of x. That's what goes in this box, x over square root of x. But the bottom can't be 0. Alright, we can't have square root of 0 in the denominator down there. So the way we end up with square root of 0 is if x is 0, so we have to leave 0 out. So before, up here, we were using a square bracket with 0 because we were including it. If we want to leave 0 out, instead we use a parenthesis. So we'll have parentheses 0 to infinity. That one changes on the division. Okay. If we can get our next page to work here. Two new functions, but same idea. Here, if we do plus, well, let's think about our domains first. So our domain for this one, we don't have any square roots, we don't have any fractions, so negative infinity to infinity. This one, we don't have any fractions, we don't have any square roots, so negative infinity to infinity. So on plus, minus, and multiplication, we're just going to have a domain of negative infinity to infinity, all real numbers. Okay, we don't have any troublemakers in there. So that's going to be our domain on the first three. So if we do f plus g, we'll have x squared plus x, that's f, plus g, so g is x squared. And if we combine like terms, we'll have 2x squared and plus x. 2x squared plus x. We could combine some like terms on that one. If we do minus, we'll have f, which is x squared plus x, minus, and it's a good idea to put a parenthesis, g of x, which is x squared. X squared minus x squared, those cancel out, leave us with x. Again, the domain's going to be the same as the last one, negative infinity to infinity. Times, we'll have f, which is x squared plus x, times g, which is x squared. Here we've got a little bit of work to do. We have some distributive properties, so if we distribute this x squared times x squared is x to the fourth. X squared times x is x to the third. No like terms there, so x to the fourth plus x to the third. Our domain is the same, negative infinity to infinity. On the last one with division, anytime you're dividing, you need to be extra careful on the domain. Okay, so dividing, we'll have f, which is x squared plus x, over g, which is x squared. Here, we can split this up, so this is x squared over x squared, plus x over x squared. And then we can simplify. So x squared over x squared is 1. And then one of the x in the top will cancel, leave us 1 over one of the x's in the bottom cancels x, 1 over x. But here, this can't be 0. It'll be undefined. So we have to leave 0 out of our domain. So the way we leave 0 out is we're still going to start at negative infinity, but then when we get to 0, we have to stop and leave it out, so we have a parenthesis. And then we're going to start right after 0, so parenthesis 0, and we're going to go all the way up to positive infinity. And since we have two pieces, we do the union symbol. So anytime you leave a number out, you're going to have that number with a parenthesis, union symbol, and then a parenthesis with that number again. Okay. That's that. Number 12. We got some composition to do here. So on this first one, we're doing f of g of 0. So to find g of 0, we'll plug in 0 here. So that's 2 minus 0 squared, 2 minus 0. So that's just 2. So this is f of g of 0 is 2. Okay. Now we're going to take 2, plug it into f. So we'll have 5 times 2 minus 6. That's 10 minus 6. We get 4. Okay, so for f of g of 0, we get 4. Got to make sure you're doing things in the right order. Now if we do it the other way around, part B gets us to do it the other way around, so do a different color. So g of f of 0. So to get f of 0, we plug 0 in here. So that's 5 times 0 minus 6. 5 times 0 is 0. 0 minus 6 is negative 6. So this is g of negative 6. Okay. So now we take the negative 6, plug it into g. We'll have 2 minus, and be careful with the sign here, negative 6 squared. Good idea to use parentheses. So negative 6 squared is 36. And 2 minus 36 is 34. So for that one, we get 34. And remember, most of the time, if you switch the order, you're going to get two different answers. So that's expected. Number 13. Still dealing with composition. This time, we don't have a number, we have an x here, and it gives it to us with this open circle notation. So if we want to find f composed with g of x, that means g is going to be on the inside. That's what we're finding on this one. Okay. G of x is x plus 6. And now we're going to take this x plus 6, plug it in for x in our function f. So instead of x squared, we're going to have x plus 6 squared. So our new function is x plus 6 squared. Okay, and don't worry about the domain. That just kind of snuck in. Okay. What about if we're doing g of f of x? So g composed with f of x. Do blue again. That means f is going to be on the inside. F is the closest to the x. So f of x is x squared. So we want g of x squared. And we're going to plug that in here. So instead of x, we're going to have x squared. So x squared plus 6. So there's our answer, x squared plus 6. And again, don't worry about the domain on these. Next one says find f composed with f. That's a little weird. I'm going to move our function down here. So f of x is x squared. I'm just rewriting that so we don't have to scroll back and forth. Okay, so f composed with f means f's going to be on the outside and on the inside. So f of x is x squared. Now this says we take x squared and plug it in for x, so we're going to have x squared squared, which is x to the 4th, right? You multiply the exponents, so x to the 4th. And then g, I forgot what g was. G is x plus 6. Drop it down. Okay, so if we do g composed with g, g goes on the inside and the outside. G of x, x plus 6. Now we want g of x plus 6, so we're going to plug x plus 6 into x, so we'll have x plus 6 plus 6. And when we combine like terms, we get x plus 12, 6 plus 6. And don't worry about the domain. Okay, 14 gives us the graph of a function Is determine if it is 1-to-1. So if we're looking to see if it's 1-to-1, we do the horizontal line test. So here I see if we draw in horizontal line right there, it's going to touch our graph more than once. So that means no, this function is not 1-to-1, which means it does not have an inverse. (15) says assume that f is 1-to-1, so that means it does have an inverse. It tells us if f of 5 is 15, what's f inverse of 15? Well, you just go backwards, so it's going to be 5. Remember, the inverse function just switches x and y. Part B says if f inverse of 30 is 15, what's f of 15? Well, it's going to be 30. It just goes backward. (16), last one, says find the inverse function of f. So remember, this is the one where we have several steps. So step 1, we're going to change f of x to y. Step 2, we're going to switch x and y. So we're going to have x equals 2 minus 5y. Get us some more room here. Step 3, we solve for y. So I'm going to subtract 2 from both sides. It's going to give me negative 5y cubed. Then I'm going to divide both sides by negative 5. So now we're down to x minus 2 over negative 5 equals y cubed. But we don't want y cubed. We got to get rid of that third power somehow. So the way we do that is we take the cube root both sides. Those will cancel. So y cube root of x minus 2 over negative 5. Okay, so there's our new function. This is f inverse. Okay, so this will be our answer here. Alright, and there's several more of those back in the homework if you want to go back through that section with the 1-to-1 inverse functions. Okay? Alright, let me know if you have questions.